Alrighty guys, there's a lot of guys wanting to see video of my explanations for each one of these topics. Unfortunately, the GoPro is dead, so I'll be using my cell phone tonight. Try to bear with me, and hopefully everything turns out clear enough that you guys see what I'm discussing and what I'm pointing at here. For tonight's Cam 101, I want to discuss two of the most often talked about specs, and that's degrees at a certain lift and lobe lift. Just recently got this cam back. What we'll be discussing tonight is a CRF 110 cam. And the listed spec from the cam company is 230 degrees duration at 40 thousandths and a lobe lift, both intake and exhaust, of 188 thousandths. So what we'll do is we'll kind of double check those specs. Ideally, to get to check it 100% and confirm these specs, you'll either need a cam doctor or you'll need to install the camshaft in the head of the engine, put a degree wheel on it as well as an indicator, and go through the motions of degreeing the cam to make sure those specs are correct. But that takes a lot of time, and most guys don't have the patience for it. So this is a little quicker way to figure out your specs. It's not the most accurate form of figuring out duration or lift. Reason being is your dial indicator, more times than not, will not have the same radius or contact area as the tip of the rocker arm. In this case, the CRF 110 uses roller rockers. What I mean is the radius right here where it would contact the lobe of the cam. So with that said, let's take a look at the setup here and what you'll need. So there's two ways you can do this at home. You can either do it on centers if you have a lathe or a truing stand, or you can put the cam on V-blocks and do it that way. Out of the two routes, the on-center route is the more accurate route to do it, but keep in mind that either route that you take, it's not going to be as accurate as doing on a cam doctor or placing the cam in the engine and actually degreeing it. So keep in mind, and I can't stress it enough, that this is only giving you a rough guess as far as your lift and your duration. Lift specs will be relatively accurate, assuming the rocker arms are not an offset ratio. If it's a 1-to-1, whatever you see here on the indicator is approximately what the valve will actually lift. So next, you'll need a indicator, you'll need a degree wheel, and you'll need a pointer. After you get it all set up, what you're going to do is you'll find the lowest part of the heel of the cam, and you'll set your indicator on 0. And what you'll do then is rotate the cam the same direction as it rotates in the head as the engine is operating. And you'll continue to rotate until the lobe lifts the indicator at 40 thousandths in this case. So I'm going to stop and kind of discuss that for a minute. The list specs are just specs quoted by the cam company. Here in the States, there's two that are often used. For the motorcycle industry, 40 thousandths is often used because a lot of the motorcycles are from overseas. And overseas, they work in metric system. And 40 thousandths is approximately 1 millimeter. If we're talking about the automotive world, here in the States, 50 thousandths is pretty much the standard for cars, trucks, things of that nature. With that said, this cam was quoted at 40 thousandths lift, so that's what we'll go with. Once getting to 40 thousandths, you'll then come over to your degree wheel and your pointer and see where you land at on the degree wheel. I already previously set this all up and set it to 0 to make everything easier to see and kind of calculate. If you do this and it happens not to land on 0 and it lands on some oddball degree, I found it easiest to take like a dry erase marker and kind of pencil it in a little bit. That way, that's where you started and you don't lose track and have to do it all over again. Upon figuring out what degree you stopped on at 40 thousandths, you'll then go back over and continue to rotate the cam till it's max lift and pull your spec from there, which the listed spec was 180 thousandths. Looks like we're about 186, 188 thousandths. Once you hit max lift, you'll start to go the other side of the lobe until you hit 40 thousandths opening on that side of the lobe. Upon stopping at 40 thousandths, you'll then go back to your degree wheel. So we started at 0 degrees and we traveled 90, 100, 110, 115, and it may be a little hard to see on the cell phone, but it's between 115 116 degrees. To make the math easy, we'll just say it's 116. So assuming that that landed on 116 degrees, then you have to figure it out. You're probably thinking, well, Chad, the listed spec was 230 degrees and you got 116 degrees. Keep in mind that it's a 2-to-1 ratio. For every time the crank revolves one time, the camshaft is going to revolve twice. So you got to multiply whatever you get on your degree wheel by 2. In doing so, we get 230 degrees duration at 40 thousandths, which, comparing it to the listed spec, we're relatively close, even though we already know that the radius of our indicator is not the same radius or contact as the roller tip. And we also found that the lift spec is within a thousandths and a half of what the listed lobe lift was. After doing this for one lobe, in this case we were doing the exhaust lobe, we write our specs down and then we move on to the intake side of things and repeat all the steps that I've just listed. Hopefully this kind of shed some light on it for you guys to understand the duration at a certain lift and the lobe lift numbers. From here, I'm going to stop camming, and we'll move on to rocker ratio and how that affects lift.